A locomotive starts climbing a grade it was purpose-built to conquer. Halfway up, boiler pressure collapses, falling from 210 pounds per square inch to 120 pounds per square inch. 6 cylinders choke. Brake lines rupture. 124 feet of iron and ambition grinds to a dead stop on the very hill it was designed to dominate. The newspapers had a name for it: the steam monster. This may be the most ridiculous steam engine that ever ran. But the real mystery isn't why it failed. It's how serious engineers, serious money, and grand promises created something this spectacularly doomed. Official records list it as the Erie Railroad Class P1, but among railroaders and mechanics, it was known by a name that belonged more to legend than to a work order: the triplex. Built by Baldwin Locomotive Works between 1914 and 1916, the triplex was a machine that seemed to defy the logic of its own era. Its full designation, 28882, reads like a dare: 2 leading wheels, 3 sets of 8 driving wheels, and a trailing pair, all stretched across a frame that measured 124 feet from coupler to coupler. The first of these monsters rolled out of Baldwin's shop stamped with serial number 61953 and christened Matt H. Shea, after a beloved Erie employee. 2 more followed, numbered 5015 and 5016, each one a rolling experiment in excess. The builder's ledger describes a locomotive with 6 cylinders, a single boiler, and, most bizarre of all, a powered tender, the only mainline steam engine in America to drag its own coal car with driven wheels. Photographs from the Erie roster show the triplex dwarfing every other engine in the yard, its bulk so outsized that it barely fit the frame of the camera. The nickname Steam Monster was not just newspaper hyperbole. It captured the sense of disbelief that greeted the triplex wherever it appeared. Every detail about this locomotive seemed to push against the boundaries of what steam technology could handle. The wheel arrangement alone, never repeated before or since, turned heads in engineering circles and drew crowds of curious onlookers at every stop. Yet behind the brass builder's plate and the ceremonial christening, the triplex carried the burden of impossible expectations. Its very existence was a kind of provocation. Could brute force alone conquer the steepest grades in American railroading? The answer would come soon enough, not in the language of promotional brochures, but in the harsh arithmetic of the rails. Steam's golden age was an arms race of iron and ambition. From the turn of the 20th century through the 1920s, every major railroad and builder was caught in a contest to haul more freight, faster, and over tougher ground. The accepted wisdom favored brawn, longer boilers, more driving wheels, and engines that could muscle 1,000-ton trains up mountains without breaking a sweat. Industry leaders like Lima, Alco, and Baldwin churned out ever larger machines, each one a rolling billboard for progress. Trade journals from the era read like scorecards, with tractive effort, axle count, and boiler size measured down to the pound. Yet, for all their bravado, these giants played by a strict set of rules. Axle loads rarely topped 70,000 pounds. Boilers were sized to match the cylinders they fed, ensuring that power did not outstrip supply. Even the largest mallets and superpower engines were built to fit standard turntables and bridges, their speed capped at 30 miles an hour for heavy freight. The logic was simple: an engine could be as big as you dared, so long as it did not break the rails beneath it. But the pressure to outdo the competition sometimes bent these rules to the breaking point. Railroads craved a single machine that could replace double headers, cut down on crews, and conquer the steepest grades. Builders, eager for contracts and headlines, were quick to promise the impossible. The result was a climate where radical designs, once dismissed as fantasy, suddenly seemed like the next logical step. In this world, the line between innovation and excess blurred, and the doors swung open for ideas that were as risky as they were grand. George R. Henderson, Baldwin's chief engineer, was no stranger to big ideas. By the summer of 1913, the Erie Railroad's board had grown impatient with the slow, costly ritual of double-heading helpers up Susquehanna Hill. They wanted a single locomotive that could do the work of 2, maybe even 3 conventional engines, and they wanted it to run with fewer men, less fuel, and more certainty. Minutes from Erie's June board session spell out the mandate: eliminate helper swaps, cut crew costs, and set a new record for freight power. The board's optimism was contagious. Baldwin's sales department seized the moment, promising a machine that would not just meet these demands, but redefine what a locomotive could be. Henderson, a man whose notebooks brimmed with untested concepts, saw a chance to leapfrog the competition. He argued that compound articulation, stacking engine units and spreading the load, could multiply power without overwhelming the rails. In private memos, he wrote of a locomotive so strong it would make helper engines obsolete. Baldwin's 1914 sales brochures went even further, advertising a 30% reduction in fuel per ton-mile and the ability to move a ton of freight with the ease of a streetcar. The triplex, as it would be known, was pitched as the most powerful single-unit steam engine ever built, a machine that could haul trains previously thought impossible. Erie's directors, eager for headlines, signed off on the boldest order in the company's history. The contract called for attractive effort that dwarfed anything on the rails, with penalties for late delivery and bonuses for performance. Henderson and his team at Baldwin set to work, convinced they could deliver on every promise. In the boardroom and the design office alike, the mood was buoyant. Ambition had found its perfect project. Only later would the fine print of physics and operating reality begin to catch up. Blueprint sheet BTR P1 1914, sprawling and meticulous, mapped out the triplex's mechanical gamble. Under George Henderson's direction, Baldwin's engineers drew 3 articulated sets of driving wheels, each designed to flex around curves, but the last set, in a move that startled even seasoned railroad men, sat beneath the tender. Instead of a passive coal car, the triplex's tender became a powered unit, its own 8 wheels, driven by cylinders, turning what was once dead weight into a force of motion. 6 cylinders in total, 2 high-pressure cylinders at the front, and 4 low-pressure cylinders split between the center and rear, were all fed by a single boiler. The arrangement, a 28882, pushed steam engineering to its limits. The powered tender was more than an oddity, it was a statement. No other mainline locomotive in America asked its tender to do anything but follow. Here, the tender pulled, distributing adhesive weight and promising to wring every ounce of traction from the locomotive's massive frame. On paper, this meant more power on the rails, but in reality, it introduced a new set of headaches. As coal and water vanished mile by mile, the tender's weight and its grip dwindled. Shop crews faced a maintenance puzzle that grew more complex with every trip. Baldwin claimed the triplex could deliver 176,000 pounds of tractive effort, enough to move a 7,000-ton train up a steep grade. No other locomotive matched those numbers. But the promise came with a catch. 6 cylinders demanded steam from a single boiler, splitting pressure 3 ways. The harder the engine worked, the faster it starved itself. Henderson's notes brimmed with ambition, stacking engine units, multiplying power, conquering mountain grades. Yet the complexity of steam pathways, the challenge of synchronizing 6 cylinders, and the unpredictable powered tender raised doubts before the first triplex ever rolled out. The blueprints promised a revolution. The reality would prove far more complicated. Paper promises and boardroom bravado didn't translate into enthusiasm on the ground. The triplex arrived with fanfare, but depot logs from Port Jervis and Susquehanna read more like confessions than triumphs. Crews treated the assignment like a punishment. Firemen swapped shifts, engineers swapped stories, and the dispatcher's office became a clearinghouse for last-minute trades. According to union notes from the Brotherhood of Locomotive Firemen, the triplex roster was the least requested slot on the line, so unpopular that seniority rules were bent just to fill the cab. Anecdotes from the era have the ring of gallows humor. One fireman, Bill Harper, wrote in his diary that he'd rather shovel snow than coal for that beast. Another, quoted at a 1920 union meeting, claimed, "You could hear the triplex's whistle and know someone drew the short straw." Scheduling became a logistical headache. The engine's sheer length meant it couldn't fit on standard turntables, so it had to be spun at special facilities. If the triplex was delayed, entire freight sections idled, waiting for a crew willing or desperate enough to take it out. Depot managers documented a pattern. Whenever a triplex appeared on the assignment sheet, absenteeism ticked up. Crew rosters show names crossed out and replaced again and again. Maintenance logs tell of firemen requesting transfers, citing exhaustion, and the relentless pace of feeding 6 cylinders from a single firebox. Dispatchers, caught between the demands of the board and the reality of the rails, found themselves shuffling trains, juggling personnel, and fielding complaints from every direction. The paradox was plain. Here was the most expensive, most powerful engine on the Erie's books, and yet it gathered dust between runs. The company had invested a small fortune in engineering and infrastructure, but on the human side, the triplex was a burden no one wanted. Crew resistance became as much a part of its story as its mechanical quirks. The numbers soon told their own story: empty cabs, missed schedules, and a locomotive that, despite all its promise, was already on probation in the eyes of the people meant to run it. Test engineers gathered around the triplex with clipboards and stopwatches, ready to measure what the salesman had promised would be a revolution in freight power. What they found instead was a lesson in limits. Dynamometer runs on the Susquehanna Hill revealed a coal appetite that stunned even seasoned railroaders. The triplex burned through 12 pounds of coal for every tractive horsepower hour. Standard mallets managed the same work with just 5 pounds. Over a 30-mile helper run, the triplex could chew through nearly 1,800 pounds of coal, double the projections in Baldwin's glossy brochures. Acceleration was no better. Performance logs from the Erie's engineering department show that, fully loaded, the triplex needed 4 minutes to reach just 5 miles per hour on a 2% grade. The timetable demanded half that. Crews reported frequent steam starvation, forcing them to throttle back or coast, and the engine fell behind schedule almost as soon as it left the yard. The numbers were inescapable: 6 cylinders, 3 sets of drivers, and a single boiler that simply couldn't keep up. Each trip became a slow-motion struggle against the arithmetic of steam. The triplex's promise of unmatched power on paper dissolved into a pattern of lagging starts, missed connections, and coal piles that grew as fast as the engine could burn them. The data, recorded in neat columns and inked signatures, left no room for excuses. The triplex wasn't just inefficient. It was a mechanical contradiction, a machine that demanded more than it could ever deliver. Inside the Gulf Summit Roundhouse, the triplex's reputation took on a life of its own. Fitters and firemen swapped stories over blackened workbenches, each tale more exasperated than the last. The maintenance logbooks from 1916 read like a litany of mechanical disasters. Boiler leaks cropped up so often that spare rivets and firebox stays had to be kept on hand, with crews re-riveting plates in the dead of night just to keep the monster in service. Within 6 months, every triplex had suffered at least one major leak, sometimes 2, leaving the floor beneath the engine slick with water and coal dust. Axle fractures haunted the rear set, the very wheels meant to turn dead weight into tractive force. 3 times per locomotive, according to the logs, a fractured axle forced an emergency replacement. Each time the engine sat idle for days while a new high-strength steel blank was machined and fitted, an operation that tied up the roundhouse and left the freight schedule in shambles. Valve gear misalignments became a daily ritual. The 6-cylinder layout meant 6 sets of rods, levers, and linkages, all fighting for harmony. Piston rods wore down at double the expected rate. Mechanics cursed the job, knowing that a single misaligned valve could turn a night's work into a week-long teardown. One fireman, quoted in the Railway Engineer, called the triplex a soup-filled furnace that sputters out before the path even begins. The risks went beyond inconvenience. Reports tell of the engine losing steam mid-grade, stalling on the hill, and rolling backward toward a following train. Each trip carried the threat of mechanical failure, an ever-present sense that the next leak, the next fracture, the next misfire could spell disaster for crew and cargo alike. For those assigned to the triplex, reliability wasn't just a headache. It was a gamble with every run. The triplex's sheer size put it at odds with the very network it was built to conquer. At 124 feet long, the locomotive stretched nearly 10 feet beyond the Erie's largest turntables. Routine moves became logistical puzzles. Turning the engine required a detour to Port Jervis, where a special 130-foot turntable had to be constructed just for this machine, an expense that rarely paid off, since the triplex spent much of its life sidelined, waiting for clear tracks or a crew willing to take it out. Bridge engineers faced their own dilemma. The triplex's axle load topped 70,000 pounds, exceeding the 65,000-pound limit on several mainline bridges. Inspection reports from 1917 detail emergency reinforcements to the Lanes Bridge, a $45,000 fix that still left dispatchers nervously eyeing every crossing. Even the tunnels fought back. The Glen Lake Tunnel, with its 14 feet 6 inches clearance, could not accommodate the triplex's 14 feet 11 inches profile. Crews lowered the track bed, scraping by environmental rules and local patience to make room for the monster's bulk. Every mile exposed another mismatch: platforms too close, curves too tight, switches too short. The engine's ambition outgrew the rails beneath it, leaving the triplex with nowhere to run safely. For all the talk of power and progress, the Erie found itself reshaping its own landscape just to keep one locomotive moving, a costly reminder that in railroading, the line always gets the last word. Boiler pressure hovered at 210 pounds per square inch as triplex number 5015 clawed up the Susquehanna grade, snow swirling past the cab windows. The engineer's log records a sudden drop, pressure plunging to 120 pounds per square inch in under a minute. Steam starved the cylinders. The massive rear drivers began to slip, their iron tires shrieking against the rails. Coal vanished from the firebox at a frantic pace, but the boiler could not keep up. With the train stalled and gravity threatening to drag 2,000 tons backward, the crew yanked the emergency reverse. Air hissed through the brake lines. A sharp crack echoed from the rear, a brake pipe rupture, followed by a blast of coal dust ignited by a stray cinder. In seconds, a column of black smoke billowed skyward, blotting out the valley. The engineer's hands shook as he logged the event. Pressure loss, slip, rupture, explosion. The triplex, built to conquer mountains, had choked on its own ambition. Newsprint inked the verdict before the board could. The morning after the Susquehanna disaster, headlines blared across the country. Steam monster stalls, sparks fire on hill. Triplex's name became shorthand for hubris. Its failures dissected in editorials and lampooned in political cartoons. Railway Age called it a monstrous misadventure, while the Erie Gazette demanded accountability for risking lives and property. Within 72 hours, the Erie board convened in emergency session. The minutes record a unanimous vote. All triplex locomotives were withdrawn from service, effective immediately. No dissent, no debate. The engine that once promised to outmuscle the mountains now faced exile, its fate sealed not by a single flaw, but by the spectacle of its collapse played out in the national press. The board's decision closed the chapter on the triplex's career, leaving only questions in its wake. Today, the line between visionary and folly grows ever thinner. As industries race to outdo the past, the specter of over-engineered ambition still haunts innovation. The Erie triplex endures as a monument, not to failure, but to the peril of mistaking spectacle for progress. Every generation builds its own steam monsters. The question is whether we recognize them before they grind to a halt. Share your thoughts below.